My name is Darren Miller. I'm a distinguished technical marketing engineer, and I was asked today to talk to you about innovations in network security policy. We have a lot of new products that were announced at Cisco Live and that are upcoming. So what I wanted to go and do was give you an overview and give you sort of a level set of how we're approaching these innovations. And it all starts with what's called zero trust networking. Then I'm going to review a new announcement, what we call endpoint analytics. It's really focused on endpoint visibility in campuses and branch and OT environments. And then we're going to talk about group-based policy analytics. So basically, once you have identified devices when they're on the network, what do you do with it? How do you create an assessment of those endpoints and what their network profile is? And then we're going to talk about scaling out network security policy. There's been lots of islands of security policy that have developed over the years, and we're starting to bring those islands together. And then finally, a wrap up. So let's get started. So basically, we want to start and put the context around this about zero trust, because zero trust is not only a hot marketing term within the industry, it's also a set of principles that enterprise security architects are using to build out, enterprise security networks. And the basic premises started a long time ago but it's founded on the notion that we're eliminating network trust. What I mean by that is we're eliminating static objects. So if we think of an IP to a network object as it exists in a firewall manager, that's a static structure. If we think of a user and a password, that's a static structure. So you've seen over time that we're starting to eliminate those static structures. We've gone to MFA in almost all of the applications on the internet, and we've also gone to dynamic classifications inside of the network structure. And then once you do that, then it's basically securing network access, which is at least principal architecture, which has been around for ages and ages. But fundamentally, what we've done with enterprise networks and the internet at large is we've created fast, cheap, ubiquitous connectivity. That comes with risk, and that risk needs to be mitigated through a least privilege strategy, going from a default allow, hopefully over time, to a default deny. And then once you have that, you have to continuously monitor that. You can't just put policy in place, because threat vectors exploit, legitimate policy in many instances. So you need to be monitoring that activity. So the way Cisco approaches this is we come at it and we have three principles: securing the workforce, so the end users at the application layer. We use Duo and AMP and other endpoint technologies for that. And then securing the workplace, which is the focus of this presentation, which is focusing on the corporate network and the interaction of the corporate network with those different users and their underlying devices. And then finally, securing the work load, which is our tetration offering to market. So as I said, we're going to be focusing on securing the workplace. So this is primarily driven out of our campus and branch environments, as well as connecting it to different parts. So one of the things we've been able to do for a long time on the enterprise network is establish trust that I talked about earlier. And we have had a way with the Identity Services Engine and DNA Center to provide a dynamic assessment of users and endpoints as they come on the network. Then we can segment that, and we have a number of different ways to do it. But really, we have to start building out multi-domain strategies in order to do that, with the evolution of software-defined networking in the WAN and in the local LAN and in the data center. And then finally, how do we continually verify what's going on and create visibility? So what's in italics and bold is what I'm going to be talking about today: endpoint analytics, group-based analytics, and then finally scaling out enterprise security policy. So let's look at endpoint analytics. Endpoint analytics is basically about addressing a challenge where a large percentage of the endpoints on the network are unknown. You try to authenticate with 802.11i with .1x, but there's a large percentage of devices that don't have WPA2 Enterprise or WPA3 Enterprise, and they need IPSK. And when you do that, you don't have the ability to really identify what they are. So we need to identify them in order to mitigate the rise in these kinds of devices and the risk they bring into the environment. So I personally was involved in an incident response where basically we had a legitimate device download an image from a legitimate supplier. That supplier didn't know that on the back end that they had been compromised, and they had malware inside of their firmware, and that firmware then spread laterally through a number of different networks and took out a large enterprise, environment. And so we need to have mitigation techniques for this. So one of the ways that we do it is endpoint analytics. As I said, we want to go from the question mark, the unknown, and go through a series of technologies to figure out what the devices are. So endpoint analytics combines a number of different technologies. The first is deep packet inspection. The second is network telemetry probes. Now, we've had this in the identity services engine and in the network devices themselves, flow data as an example, for a number of years, but we haven't been able to put it together into a product to answer this specific question. It always existed in, threat-centric security views, or it had existed in just very simple network probes like what was in the identity services engine. But we have to combine that with a normal operational process that customers have in manufacturing, that they have in universities, where they have onboarding tools that can identify what the endpoint is through a number of different techniques. And we want to put that data into the overall system in order to classify it. So we know that we're not always going to be the source of truth for an endpoint classification as it touches the network. So we have to have access to CMDBs as well as third-party tools in order to fully integrate this solution. So the way we want to do that, if we compare endpoint analytics to what we had previously had in the identity services engine, the identity services engine used a number of protocols, Radius, LLDP, CDP, as well as DNS or active probes like SNMP and Nmap to try to fingerprint an endpoint. And that worked relatively well, but there was still a large amount of devices that would come onto the network that would be unknown, because through those techniques, you would fingerprint the IP stack. But because people were buying off-the-shelf IP stacks, as we've seen in the recent release against an IP stack provider out of my home state, actually, Ohio, there's a number of different vulnerabilities, and we had only identify it as the third-party manufacturer of that IP stack. So we needed to layer on more information, such as DPI, integration into third parties, as well as crowdsourcing via machine learning, to really start to identify what the endpoints are. So what's this sort of look like? So if we look at the deep packet inspection, one of the things that we found in a lot of the embedded protocols that are used in medical environments and other environments is the actual packet will transverse the network. We'll combine that with a probe. If we use passive probes in the past, we would only have seen Microsoft. But if we look at the actual packet, it'll actually tell us it's a DICOM GE CT540. And then from that, we can understand what kind of operating system it is. Now, as an example, Windows 7 has gone end of support, end of patch. So this is a very predominant operating system, not only in medical environments, but also in manufacturing and others. So it's a risk. If there's another day zero, and there will be, identified in the operating system, there's no way to really mitigate that unless you can identify the device and build a network profile around it that says what the allowed protocols are on the environment. But in addition to that, we want to use that to make a network segmentation decision for least privilege, to go back to those zero trust principles. And the way we would be doing that is using the information out of DNA Center and out of Endpoint Analytics and giving it to the endpoint or the identity services engine, which is the runtime for our network segmentation strategy. So it basically would take the information in from DNA Center and then authorize devices in the network as they showed up or moved around the environment. So this is really a foundation to be able to classify, and be able to enforce policy for these unmanaged endpoints that don't have necessarily a user behind them. So in addition to deep packet analytics, we want to start using, machine learning and other kinds of clustering information in order to identify these devices and crowdsource it, because the number of devices that come onto the network is increasing every day. And as I said, they generally are using these, off-the-shelf third-party stacks. So what we want to be able to do is we want to be able to acquire data from a number of different sources, ICE, third parties. We want to send that data from the on-prem data lake into the cloud. And then we want to run machine learning against it. And the more data that we can get from the environments, the better our machine learning has become. And so it's allowed us to cluster things inside of the cloud and then build rule creation about the different unique groups that are exhibiting the same kind of communication patterns and the same kind of characteristics that we can derive from the probes that we have. And then we actually give that back to the customer, and the customer tells us what these different clusters are. So in this example, it's Bosch coffee machines and Apple watches. Now, what's sort of interesting about that is this is a real use case where we've got coffee machines connected to the internet. It used to be, that it was a university lab environment that people would, want to have telemetry coming out of these coffee machines, so that they could figure out if the next cup of coffee was ready or if a fresh pot was ready. Well, that is actually one application, but the other application is for inventory management. It's for servicing the machine, and so these kinds of connectivity in the environment happens. So basically, what we're trying to do with endpoint analytics is develop a multi-factor classification function. Be able to understand the device type, be able to understand the hardware manufacturer and model as well as the operating system, because just because we put these into groups of classifications doesn't mean that it's a business relevant group. So what we're trying to do here is give the end user all of the relevant information to say that this endpoint belongs to building automation. This endpoint belongs to security systems. This endpoint belongs to a medical clinical engineering environment. And then the customer can use other tools, one I'm going to talk about next, to basically build the functional role in the environment so that they can start moving from an open network to a closed network. So endpoint analytics is really trying to move those agentless devices from unknown into known structures. But that doesn't really solve the full problem, right? Because once you have an endpoint identified, really the question for network security is, what do you do with it? So we have a tool that we've developed called group-based policy analytics that's really about looking at the network profile and then building analytics in order to answer that question. So the challenge that our customers have happened, high-profile attacks have happened, whether an actual adversary or just malware that's propagating haphazardly through the network. And people want to mitigate those problems, but they largely have a network that is unknown. They don't know what the network profile is of the applications. They don't even know what the applications are in some instances. And they don't know what the patterns of good behavior versus bad behavior are. So it's difficult for an administrator to understand that behavior of a person or a network or a thing. So customers are asking for help. So we're developing a tool. It's based on DNA Center. It's called Group-Based Policy Analytics. And it's really going to do two things. What we're releasing first is the discovery of visibility and behavior. So how to answer the question of what is the network profile of this particular endpoint and what is it communicating to? That's what we're answering in the first release. But in subsequent releases, we're going to be able to model basically, if I created a deny over time, what would it do to my network traffic? And then author or push the actual policies down into the network security controllers. Short term, that's going to be a manual process, steps 2 and 3, but it's something that we are going to be automating in further releases of this group-based policy analytics application. So what does it really look like? So DNA Center is an aggregator of data, not just, endpoint data, which comes from ICE, or the gray in the upper left represents third parties, but also it comes from the endpoint analytics application that's native to DNAC, or Stealthwatch. Stealthwatch is very prevalent flow telemetry source, and they have classifications of source groups, as well as finally, general net flow if you don't have a Stealthwatch or if you don't have, some other collector. And what we're trying to do is we're trying to take information from a number of different areas that don't go into the classification of the endpoint per se. They go into the classification of the functional role in the enterprise environment, because you might be in a medical environment and the functional role of the CT scanner is imaging, or the functional role might be medical or clinical engineering, as opposed to what the specific device is, because there are thousands or tens of thousands of actual device types, but they might summarize into 10 or 15 different functional roles within the environment. So once we have that, then we want to visualize what can be seen in the environment and maybe what can't be seen in the environment. So this is just an example of how we can visualize. It's called a Sankey chart. It's a very popular visualization tool at the moment. And basically, we can see that energy control is speaking to HVAC and lighting and water control. So that sounds like a viable set of groupings that it should be talking to in a functional environment. But you also see that it has this unknown communication. So that is an example where not only do we want to move endpoints from known or unknown to known classifications, but we want to move network traffic or network profiles from a known or an unknown classification into a known. And that's really what group-based policy analytics is all about, is moving that classification from an unknown into a known.
Darren, may I stop you and ask a question?
Absolutely.
Does this require, I understand running DNA Center and maybe just using the assurance engine, having ICE for your SGTs and all that stuff, right? Does this require running a full SDA fabric, or can someone just use the DNA Center appliance and the assurance engine integrated with ICE?
Great question. They do not have to have a full-blown SDA environment to use this tool. That was one of the big discussions internally, was, how do we encourage people to go to an SDA environment to get the ease of use and ease of deployment for segmentation. And this was one of the ways we're trying to encourage people to move to that zero trust model that you can implement with SDA. So we do have a way to deploy the DNA Center appliance and assurance out of band on an existing environment and then build out these tools. Did that answer the question fully?
Yeah, it was a pretty straightforward question, I think. But that's great, because I do have folks that I work with quite a bit that are really interested in DNA Center, including the assurance piece, but are somewhat reluctant to go to the full fabric just yet. We have the conversation, of course, but we're not quite there with some folks. But the analytics piece is so compelling that to be able to do that with an environment that's kind of like with, again, just the assurance piece, that's great. That'll work.
Yeah, as you can tell, hopefully by my smile, that I fully agree with you. I think the more data that you can analyze, the more power you put into the end user's hands, the better they can make an informed decision. Because one of the biggest challenges with moving to network segmentation is that we built these networks on purpose, very, very open and fast. Right now, we have to move to a more controlled environment, and the only way we're going to be able to do that, from my experience, is by giving them information like this. So one of the things that we constantly hear is, wait, this is built on flow data. How does it compare to Stealthwatch? So one of the things I wanted to do in this presentation was to take a moment to say it's the same data that both teams look at, but they look at the data differently. So Stealthwatch is a threat-centric tool. It's a threat hunting tool. So it is really built to analyze the data to go after active threats, right? So it is really looking for all of the low-level compliance kinds of issues. Group-based policy analytics is using very much the same data, but the difference is it's trying to do modeling and it's trying to do real-time visibility. So we're using the data differently in the two different applications. So there's a number of different patterns like this that you can find in a number of different, white papers on data, analytics and machine learning and all of this different thing. And the key is that it's the same set of data, and we are building synergies between the two products to exchange that data, but we're using it for slightly different use cases. So at the end of the day, as I talked about, we want to be able to use this to not only model the positive aspects of approved communication, but we also want to use this as a way to catch, communication in an environment that's happening that we might not approve of. So, the gray represents, employees talking to email servers and different unknown classifications on the internet, which is fine from a network security perspective. But then you can also use it to see that guest is talking to a database server. Yes, it's a little bit of a contrived example, but it's an example of what we have done. But we've also had scenarios where we use it to analyze and then figure out legitimate traffic. So an example I give and talk about is that we had this analysis being run against an MRI machine, and we saw the MRI machine making a call out to iTunes. And it immediately made us ask the question, wait, should an MRI machine be calling to iTunes? So we were able to look at the traffic and figure out when it was occurring, and it matched customer MRIs. So basically, the MRI machine had a very legitimate reason for reaching out to iTunes. The headphones that the patient wears during the MRI is actually sourcing the music from iTunes in that scenario. So it's a legitimate use case. So we actually used the tool to, understand the traffic flow and then figure out if it was allowed or unallowed traffic in the environment. In this scenario, it turned out to be allowed. So we want to be able to create those specific ports and protocol matches.
Aaron, is that where Stealthwatch comes into play, where you're de-authing, re-authing, or killing a port or something like that because it's anomalous behavior?
If you would want to take that positive action back and kill the environment because it's anomalous behavior, like if you wrote the rule guest to database, yes, Stealthwatch absolutely could be that tool that reaches back into ICE and kills the port and make sure that it's blacklisted. We're working with other vendors to do that same exact scenario. So one of the points I would make is that we're trying to make this entire system open and API driven, so that we know at Cisco, we are not always the full, IT security stack. So the name of the game in IT security is build APIs and integrations. So this is absolutely an example of that.
Okay, thanks.
So yeah, thank you for the question. So if we're looking at sort of end to end, how we put this together, the very first thing we need to do is, analyze the endpoints that we can't interrogate and know there's a user or a machine credential on a Windows device to identify it as our asset. So we want to use endpoint analytics, but then we want user classification through the normal .1x means. Once we have both of those things, then that's when we really start to build this group-based policy analytics, and we can look at the ports and protocols that are used, build out a policy, and then push that into DNA Center and the Identity Services Engine to do the actual enforcement. So that's the full life cycle that we're going for. And these two introductions of endpoint analytics and group-based policy analytics really refine and smooth off the edges so that it becomes a much more approachable problem for a broader part of the market. And that's really our goal. So once we've done that, right, what we have found is that we need to scale network security policy. So what do I mean by that? So I have customers with tens of thousands of remote sites. That sounds crazy, but it is something that does happen with little microsites, as well as telecommuters now. With the explosion that we've had in telecommuting, that becomes a microsite, but I still need to apply an end-to-end security policy there. So we've had a couple of innovations where we create fabrics, so software-defined access fabric, or we would create an ACI fabric, and we would have to communicate between those two fabrics. And traditionally, we would basically end the classification, end the virtual network at the border. That's what the B stands for. And we'd have to use things like VRF Lite or MPLS to communicate between the different fabrics. What we've done is we've introduced a software-defined access transit, but also software-defined access to SD-WAN transit so that we can connect those two different things together. So the note says Q2 of calendar year 2020. When we originally had Tech Field Day scheduled, that was still an upcoming date. It is now a shipping date where we do have the shipping to general availability. So what does it sort of look like? So in SD-WAN to SDA to SD-WAN, basically what we're doing in our first phase is we have different borders. We have a border for SDA and we have a border for SD-WAN. And so SD-WAN manages a router, what we call a Cisco Edge. So an ASR1K, an ISR4K. And there are switches behind it. And what we do inside of the data plane is that we have an SGT and a virtual network identifier in SDA, and we need to translate that into what is the VPN in SD-WAN speak and carry the SGT. So we have released that. It's in iOS XE 17.2 support. And it will allow us to communicate an SGT from the left fabric all the way to the right fabric and implement a policy. And because the SGT and software-defined access in the group-based policy it's built on is quote-unquote topology agnostic, basically we get great scale out of this. So we basically now have network security policy scaling to the limits of the network topology itself, which is very exciting for a security practitioner, because in the past I always had, issues where, this firewall can only scale to X amount of access control entries, or this router only scales to X amount of access control entries. By being able to carry the tag across the network and do this egress policy enforcement that we have, that's how we get scale out of it, because the egress point only needs to understand the classifications of what's locally connected, not the tens of thousands to millions of endpoints that are on the other side of the network. So I know a lot of people don't really want to do egress enforcement, and they don't have to, but when they make that decision, they limit the scale of the overall solution. Now, going with this, because we can go from ingress to egress, we have almost infinite scale in the solution. So that's one way that we're doing it. The other way is we're integrating with the application-centric infrastructure in the data center. So we have a shipping solution today. It is what we call a policy plane integration, where basically we're learning information from the campus and branch environment. We're learning information from APIC. We're consolidating that into a table, and we're delivering that out to an enforcement point. So that works relatively well, but it's not VRF aware, and it doesn't allow a simple integration between the virtual networks in SDA and the tenets and VRFs in ACI. So we needed to improve upon this solution. So what we'll be shipping at the end of the year is that integration, where we will be able to extend the virtual networks from SDA into the tenants in ACI and their VRFs, and then ACI will be able to build policy between those tenants and VRFs, the VNs, and whatever the application resources are in the ACI fabric. And we'll do this with great scale, because again, we're doing this in what we call the data plane. So we're using that tag to abstract away the database, basically, of IP to SGTs for anything, the number of endpoints that are existing out in the campus and branch environments. So it's a really exciting integration for me, because it allows me to scale in these software-defined networking, controller infrastructures. There is ways that we can do this with brownfield scenarios as well, and those will be tested in solution test after the initial release of phase 2, so that you can have part of the environment that is, classic prefabric, as we call it, brownfield, and another part of the environment that's SDA, SD-WAN, and then ACI.
So Darren, I have a couple quick questions, if you don't mind.
Absolutely. Absolutely. Yeah. I was being told that I needed to move forward with time so that we can answer questions like this. So
okay,
good.
Yeah, you're definitely getting to the end-to-end story here. You just brought up ACI as well, so I think we all knew this is where you were going. Does this mean, though, that we're going to be consolidating any kind of management features? I saw one of your bullet points was managing SDA border nodes and vManage. Are we going to see like the Lisp database consolidated on a control plane node, but for the WAN, do the control plane nodes need to be bigger now because you're managing all your sites? Does that make sense?
It does make sense, and I'll try to break it down into a couple different layers, the data plane, the control plane, and then the management plane. So the data plane is what's converging here, right? And we will, see also, continued work to converge the management plane. So the policies between ACI and SDA are going to be exchanged so that you can optionally use ACI policy in the campus. So if you say user to database, that'll happen. In addition, we're, another part of Cisco, Meraki, has introduced adaptive policy, which is based upon the SGT. And they, I think talked at the first day, they're going to be introducing a policy sync with ICE. So the management plane will be converging. Over time, there's not one Uber controller to rule them all, but we will be exchanging data so that we can implement policy end to end. The data plane is converging. The control plane, because of some unique characteristics of the control planes, there's OMP in SD-WAN, there's Lisp in SDA, there's COOP in ACI. Those right now won't be converging. But if we do this right, that becomes more of an operational day two kind of issue, not a day one or day zero or day one kind of issue, because if we do our job right, and that's the question, is that should be transparent to the policy or the intent you want to express and how it gets instantiated. And so we're trying to abstract that complexity away from you, so that we have the management plane and the day two operations answering the questions in an end-to-end fashion. But I would say that's going to be an evolution over time, as you probably have seen over the last couple years, as opposed to one product that does it all. In summary, so we're really focused on leading zero trust in enterprise networks. We have a number of continuing innovations that hopefully I'll talk to you next year about, with this kind of platform. So we're really wanting to lead the securing the workplace, and we're building it with endpoint analytics. We're building it with group-based policy. We're building it with more scalable enforcement, and we're really looking to improve in the future. And, I'm lucky enough to be working on those future endeavors. So getting these products released to market is extremely gratifying, and we've had tremendous feedback from our customers, and we really look forward to continue to do the innovation in the future.
You were talking about scaling the solution. There's potentially a pile of state here to enforce or to even create that policy. Where is all that stored? You're also talking about having to translate between the different control planes.
Right.
What kind of speed is going to be included with that scale? Like speed of translating the policies and storing the policies. So what are the downsides to this?
Okay, so great question. So the way the policies get defined, because it can be a very large environment, will be built at a distributed set of tools right now. So you would build policy state in ACI, you would build policy state in SDA, and you would exchange that state, and then you manage the growth in that state by making the policies optional between the two domains. So let me give you an example of what I mean. So there are flows of microsegmentation within the data center that are not relevant to the campus. So database to database, database to backup, database to administration, jump host. Those policies are not relevant to the campus because there are typically databases exposed at that layer. So that's one way to manage the policy state. At the second level, there is what I call the group membership state. So that is endpoint A belongs to group B. And that again is distributed between all of the different controllers. So SD-WAN, ACI, and SDA. And we don't necessarily exchange all of that state. So I don't want to have to move 10 million IP to groups that might exist in software-defined access into SD-WAN and then into ACI. So that's where the data plane integration comes in, where we can basically put in an index in the data plane on the frame or the packet and send it to the next domain. And now it's significant to the next domain without having to have the group membership state exchanged everywhere. This is what firewalls do, but they have very generous compute and memory. And if they don't have generous compute and memory, you buy more compute and memory and you build a bigger appliance, right? Network devices don't have that luxury. So that's why we use the SGT to exchange the index so that we have relevance for the source so that the next controller or next domain can take an action on it. Now, one of the things I'll say is that you can't totally avoid moving some of that state around because the controller in the middle might be a midpoint. So there are pieces of domain A and pieces of domain B that you want the group membership from, but it's not the entire set of characteristics. So we're not going to be moving around all of the state for 10 million endpoints on an enterprise network, which is actually a realistic number. That's a real number that we're dealing with. But we'll opportunistically exchange state for maybe tens of thousands of endpoints. And then that can be building the, policy in the middle for, intelligent routing so that, source one going to group two goes left, source one going to internet goes right. That kind of state management will be exchanged to an extent. Did that answer the question?
Yes, it did. Okay. I have a follow-up question. No, I guess it's not
Absolutely.
Real follow-up. It's a little bit different. Does this solution negate the need for an 802.1x supplicant and port security and in the old days where they did NAC? Or because of the deep packet inspection and the profiling?
Great question. So endpoint analytics makes that better. What I mean by that is there are a number of customers that tried 802.1x on the wired. You can't really get rid of 802.1x on wireless, but they tried it on wired and didn't like it. So we've had a number of passive observation technologies, 80 login, things of that nature that allowed us to address the user population or the managed user population. But we never had anything that was passive that could really use the DPI and the machine learning to answer the non-user population. So it won't quote unquote require .1x, but what it does is it answers a large question that we hadn't been able to answer to date. And then we have a number of techniques to make .1x relatively painless through what we call an open mode, where once we get the endpoint data, then we layer in, user identity either through a passive AD agent or through an active auth on the endpoint that does little intrusion into the environment until you have a policy you want to invoke. So it's more of a passive authentication, even though we're actively probing for .1x, and we want that data if it's available. It's not required in the solution.